Swayam Prabha. Digital India. Educated India.
Okay, welcome again. This is the video series on basic surveying, and right now we are doing module 3, and in module 3 we have already done lecture number 1. Today we will be talking about lecture 2, and this lecture 2 will be from linear measurements. What all we have done so far in our lecture 1 of module 3, we talked about the meaning of distance in surveying. We said whenever we mean distance, whenever we say distance in surveying, we mean the horizontal distance, unless specified. We do measure sloping distances, but ultimately for our purpose we convert these sloping distances to their horizontal equivalent, or if not horizontal, then on the joint, depending what kind of surveying we are doing, plane surveying or geodetic surveying. Then we saw some instruments. We went to the field also, and we saw some of the instruments. For example, the chain and tape. We saw how the chain was made. It was very flexible, how to fold it, how to unfold it, how to measure the length with the chain. Also we saw various types of the tapes. What are their purpose? Why do we use the tapes? Then we saw the operation of taping and chaining. How can we measure very accurately with these instruments, particularly the tape? Tape is very precise. We can measure very precisely and very accurate distances using the tape. There are certain procedures which we need to follow. So this is what we have seen. We also saw one more important point, that was the ranging. The meaning of ranging was, if we have a length which is longer than the length of a single tape or chain, in that case we cannot spread our chain or tape in that entire length. So what we have to do, in that total length we have to put our chain or tape multiple times. So when we are putting it multiple times, we need some intermediate points in between those 2 points between which we are measuring the distance. So putting these intermediate points in between, this operation is called the ranging. We saw some methods. How can we do it directly? It's a simple case. In case of the indirect, if these 2 points are not intervisible because of certain reason, we can still establish some intermediate points by indirect ranging method. Then very important thing was the corrections. In your tape or in your chain, there is a length written, okay, 30 meter. The 30 meter is the designated length. Now we are going to the field. When you are working in the field, is that tape really 30 meter? That's a big question mark. The tape says it is 30 meter, it is written there, but while we are working in the field, in actual field conditions, is it really 30 meters? It might change because of various reasons. The temperature in the field is more than the temperature at which this tape is standard. The pull which we are applying is more than the pull at which this tape is standard. So because of these reasons, what will happen? The actual length of the tape while we are working in the field is different than the designated length. Now because of this, we need to apply corrections. Whatever measurement we are taking in the field, if we don't apply the corrections for this difference in designated and actual length, our observations will be wrong. Now what we will do, today we will see a very important thing, that is the mapping. Mapping using chain and tape. We will try to make use of chain and tape, and we will do a little exercise here itself, that how we can make a map. Then we will see what are the common problems in chaining and taping. How do we set out perpendiculars? We will need to set out perpendiculars. We will see it in course of the lecture. We will see also how to drop the perpendiculars. This is also required. Whenever we are working in the field with chain and tape, we are taking observations, we need to set out perpendiculars or erect the perpendiculars. We need to drop the perpendiculars also. Then we will also see some methods of establishing parallel lines and some obstacles in chaining and ranging. So this is what we will do today. So to begin with, we will see how we can make a map with chain or tape. So we will write it as mapping with chain, I can say or and tape. Now in order to solve this problem, first let us see what is the meaning of a map. We already know, we have already discussed what is the meaning of a map. A map is the representation of ground or terrain in our sheet. Or we can say otherwise, the map is representation not only on sheet but also maybe in a computer screen. We are bringing the terrain some way into our computer so we can do various kinds of works on that terrain when it is in computer. So a map is a representation of the ground or terrain on a sheet or on the computer. Now how to make that map, we will see now with the help of chain and tape. What I will do for that, I will start with a diagram here. Now this diagram shows, for example, let us say there is a garden and this is the boundary of the garden, and this ground is around 40 meter in width and let us say 100 meter in length approximately. Now you can visualize this kind of garden, a kind of strip in your neighborhood somewhere. Now in this garden there are varieties of things. For example, let us say there is a road. Well, then in addition there are some houses, 1, 2, some little huts or some houses are there. Also in addition to this, there are some trees. Here is a tree, there is another tree. Also maybe there is a telephone line. A telephone line passes through this garden. This is pole number 1, pole number 2, pole number 3 and so on. This is my ground. Okay? Any ground could be like this. Now we want to make a map of this and we want to make use of chain and tape for this purpose. So we will see what should be the procedure. What are the various steps in order to make a map of this. So what I will do, I will start step by. The step number 1, as you know, is reconnaissance. What is the meaning of reconnaissance? We go to our area, we observe our area, we make a rough sketch of the area and we decide, okay, what strategy we are going to make use of in order to make the map. So we do the reconnaissance, and then the principle number 2, that is about working from whole to part. We have discussed that and we will see how we are going to implement this principle when we are making this map. Now in working from whole to part, how do we implement it here? First of all, we decide about some 2 locations, because we are making use of chain, it will become very clear to you very soon. Let us say I decide, well, in my area, if you see here, I select a point somewhere, for example, let us say here. This I say a point A, I put a ranging rod at this point. This is my control point or survey station. Then I choose another control point somewhere here, which I say as B. I put another ranging rod here. So these 2 are the ranging rods. Now there could be an imaginary line between these 2 points. Let me draw the line by red color. There is no physical line in the ground, but this line is marked with the presence of these 2 ranging rods. So job number 1, when we are going to the field, is reconnaissance, locating these 2 points A and B, where these points could be. Once we have located these 2 points, job number 2 in working from whole to part is we want to measure the distance between point A and point B using chain or tape. We already know how to measure the distance. As you can see over here, this distance A and B is of order of 100 meter. So you will need to do the ranging. So we do ranging, and by doing the ranging we measure the distance between A and B. So one step here is important step, distance or the length AB measurement. You can measure it using tape or using chain. Another principle which we are going to make use here, we measure this distance not only once, we measure it, we start from B towards A, we take couple of measurements, we start from A, go towards B, again we take couple of measurements. So for the same length AB, you end up having 5 measurements, 10 measurements and so. So having all these measurements together, what you are doing, you are following one principle, that is maintaining redundancy in the observation. Well, by doing this redundancy, your final AB, the length of AB is actually the mean of all these AB is measured divided by the numbers, how many times it was measured. So this is the mean length. This is the mean length means you are more sure about the correctness, the accuracy of this mean length. Well, we know this AB measured now. What is the next? The next step will be step number 4, that is about taking offsets. Now what are these offsets? Before going to the offsets, I would like to give you one more term, and this term is called field book. Whatever we are doing in the ground, we will take all those observations and record them in the field book. The field book is nothing but a small book, and you can work in the field. You use your pencil to write on the field book, and you can write on that field book. A typical page of the field book may look like this is a single page of the field book. Okay, it's around this size, and it will have 2 very faint lines in between by red color. Now very soon we'll see what is the purpose of this, why we are going to have a field book like this. We go to the field with this field book, and we can hold it in our hand, and we can start writing on that with the pencil. Well, in this field book, if you look at the ground, we have measured the distance between A and B. A and B are our survey stations. So in the field book, for what we do, first of all, we mark a point here as A, and we mark the another point as B. So one page of the field book is nearly equivalent to the length AB. So we will maintain this ratio. Whatever we are doing in the field book henceforth will maintain this ratio. Well, going to the offsets. Offset measurement. What it is, how do we do it, and why do we do it? There in the field, if you look at the drawing, there in the field, once this length is established, I can walk along this line. Everywhere I can walk along this line. Now, how do we take the offset? Okay, I walk along this line, let us say a length 10 meter. Then over here is one telephone pole, and from this telephone pole I drop a perpendicular on my length, and this perpendicular length is 5 meter. I take this measurement because I am walking along the chain. The chain is spread here, for example. So I know this length, which is 10 meter. I have dropped a perpendicular from the telephone pole on this line, on this chain, and it measures 5 meter. Now how do I record it? To record this 10 meter I am measuring along the chain, we say this as chain edge. This 5 meter, because we are making use of 5 meter in order to locate the position of a telephone pole. So all these measurements which we use in order to plot the details, whether we are talking about the tree or the house or the tree or road or anything, all the measurements which we take with respect to the chain line to plot these details are called the offsets. So this is the offset. Now how do we record it? To record it in the field book, if you see in the map, you start walking from A to B, this offset at a chain edge of 10 is towards our left hand side, because you are walking from A to B. So on your left at 5 meter you have an offset of 5 meter. So starting from A, I told you this page length here is approximately 100 meter. So we will try to maintain that ratio. So whenever you are working in the field with the field book, ensure that ratio is maintained. So at around 10 meter will be somewhere here. At 10 meter of chain edge, you have an offset which is 5 meter towards left. So 5 meter towards left is a telephone pole. Well, so this is the record of telephone pole in my field book. I write it down 5 here. I go back to the map. In order to plot this entire telephone line, let us say this telephone pole is, again if I drop a perpendicular, the perpendicular will be somewhere here, and this length is, let us say, 60 meter. Starting from A to the foot of the perpendicular is 60 meter. So what I can do in my field book, at 60 meter chain edge, as you can see here, we have a perpendicular length which is 20 meter. Okay, the length of the perpendicular is 20 meter. So at 60 meter on my left hand, 20 meter. So this 60 is the chain edge, that's why it is being written along the chain line. This 20 is the offset, it is being written on the side, and I make another symbol for the telephone line. This is not the exact symbol, but I am just using so that you can understand it right now. In our field book, we also join these, because there in the field we can observe our telephone line is a straight line, so I can join this like this. Again in the field, you can see that the poles along the telephone line are equidistant. We can measure one of these distances. Let us say the distance between these two poles. If you have measured this distance, I can establish, well, my other pole should be here, and so on. So all these poles are located in my field book. Field book is just a rough representation of the field, but it has all the observations: 20 offset, 60 chain edge, 5 offset, 10 edge chain edge. Well, we go for some other object. Let us say a house. I take the red color now. This house again is a certain distance. So for the house, I again drop a perpendicular here on the chain line. Once the perpendicular has been dropped, I measure the distance from A to the perpendicular, to the foot of the perpendicular. Let us say this distance is 14 meter and the perpendicular is 7 meter. What is the meaning of that? In my field book, at 14 chain edge, which side it is? Again, if I am walking from A to B, it is on my left. This is on my left. So from walking from A to B on my left at 7 meter. So I am writing 7 here. So what is the meaning of this? The 14 is the chain edge, 7 is the offset, and there is a house. This is a symbol for the house. So I am writing it in my field book. Similarly, you can do it for the road. As you can see, in the case of the road, how many offsets you need to take. In case of the straight telephone line, for example here, starting from here, if I highlight it, that's my telephone line, which is straight. So because it is straight, I just need to plot 2 points, and rest of the points, intermediate points of the telephone line, can be plotted automatically. But here, in case of the road, as you can see, it is curvilinear. It's not straight. So how many offsets should I take? Well, the number of offsets that I should take will depend upon how accurately we want to plot it. Just for this length here, for example, let us say I measure the width of the road. The width of the road is measured in the field. You say, okay, the width of the road is 7 meters. Then you start taking number of offsets. Number of offsets means all these perpendiculars. Now at certain changes, x1, this is y1, at x2 it is y2, at x3 it is y3, and so on. So what do we see in the field book? We'll write it like this: at all the changes we have certain values of the offsets, and the road goes like this, because we have done all these measurements. We also know the width of the road. We had measured the width of the road, so I can show this width also here. So my rest of the road will be like this, because we have taken the offsets. So by doing this, my field book is ready. As you can see here, in the field book, all these details are shown, as well as the observations, the changes and the offsets are given. Next, what can I do? I can go for the plot. I can plot my survey. Now from the field book, because this is what you bring to the office. After bringing the field book to the office, you do the plotting. So how to make use of field book? Well, we start with, again, in my field book, there are 2 stations, A and B, which are at certain distance. We have already measured the distance between A and B, which was some value. So in my plot, this is the drawing sheet. Drawing sheet will have certain dimensions, some length, some width. Let us say it is 60 centimeter and this is 45 centimeters. First of all, my ground was 100 meter and 40 meter wide, while my drawing sheet is small. So definitely we have to decide a scale, so that that entire ground can be fit to this drawing sheet. Once that scale has been decided, what we will do, our AB length, which was measured in the field, I will convert it to the scale, and then I will plot these A and B here. Let us say I plot A and B. That's my A and this is my B. I can again draw a line between these two. Then I go back to my field book. I observe in my field book, well, moving from A to B at a distance of 10 chainage, there is an offset of 5 meter, which is for a telephone pole. So I do plot this. Going from my chain from A to B at a distance of 10 meter, I can measure 10 meter here. We have a perpendicular offset at 5 meter, and that is for a telephone pole. Similarly, I can also plot the another telephone pole, because I know its chainage, I know its offset, so another pole will be plotted. I know my telephone line is straight. I can join it. I know the telephone poles were at certain interval, I can plot the rest of them. Similarly, I can plot the houses, okay, because I knew the perpendicular offset as well as the chainage for the house. So, what our map will look like? The map finally will look like, will have the road, will have the telephone line, will have the trees, will have the houses. And as well as we like to put these two control points A and B, because we can make use of these control points later on for some other purpose. So, this is how my map will look like. So, what we have seen the entire process of making a map using chain and tape. There are many things which we need to look into. Number one was, we haven't seen in detail this offset measurement. Depending the ground, the offset measurement could be different. So far what I was saying, we have the chain line, any tree or any object. In order to plot it on the chain line, I will drop a perpendicular, I will measure the chainage x and the perpendicular offset y, and I can plot it. I can write it on the field book. But dropping this perpendicular may not always be possible. If that is the case, let us say there is a tree or there is a water pond, we cannot drop the perpendicular. We cannot find the perpendicular height. What to do in that case? Well, if that is the case, there could be, we can have two lines like this. I know the chain is for this point x1, I know the chain is for this point x2, and I know this length as y1 and this length as y2. So, this kind of offsets, the first one which is perpendicular, are called perpendicular offsets. The second one, in which we have the oblique lines, it is called oblique offsets. Oblique offsets. So, this is how we can take the measurements. Well, something more about taking the offsets. If this is my chain line, we have seen it, there is a feature which is variable. How to take the offsets? We can take the offsets wherever the feature changes its direction. We can consider all these points for taking the offsets. We need not to take the offset at each and every point because it is a straight line here. For example, here there is a certain variation in my feature. If it is a hedge, this hedge does change its direction a little bit over this area, over here. Should I take an offset also here? That is a question mark. Should I take my offsets also here to represent this variation? This depends upon how accurately you want to represent the ground onto the sheet. If your concern is you want to represent each and every variation of the hedge, yes, we should take an offset. It also depends upon the scale. What is your scale? Because you will remember, we are talking about the plotting accuracy. Can this little variation be significantly, can it appear in the map at a particular scale? That is the question. If this little variation here, which is highlighted, if it will not appear in the map at this map scale, there is no use of taking offsets over here. So, this is basically a decision which you take in the field. So, whenever you are working in the field and whatever we are talking here, we are not talking complete things. That is the beauty of the surveying. The beauty of the surveying, why I say it like this, because in the field when you are working, the field conditions are always different. You have to innovate then and there in the field by observing the feature. Okay, what my feature is like, how is it wiring, what is the scale of plot, what kind of accuracy is required. Now, on the basis of this, you take a decision. What kind of offset should I take? What kind of accuracy should be maintained in taking the offset? So, you take a decision about that. So this is how we take the offsets. Okay, besides this, we will see one more principle of surveying which we should follow here, and that is about, if you remember, the check. Always we should have some provision for a check in our survey. Now how we are going to establish the provision of check in the present survey, in the present mapping? Well, looking at the ground, if you look at the ground was looking like this, and we have made a map of the ground. Map is a representation on a sheet. Now how to check the accuracy of this map? So in order to do that, we make some provisions. For example, there in the ground, I take some observations which are independent of the survey, which we are not using in the survey, which we are not using in the plotting. For example, what I can do, I can also measure the distance between this tree and the building here. I can measure the distance between the telephone pole and a building here. Well, these two distances are measured independently there on the ground. Then I go to the map. Here in the map, we have the building, we have the tree. I can measure the distance also on the map. So we have a distance AB, let's say I write it as AB, measured on the map. We have the same distance, let's say I am writing it as AB. Don't confuse with this capital AB. It's the distance between those two objects. In the ground, I multiply this small AB with this scale. Ideally, these two should be same. A distance measured in field should be same as scale multiplied by the distance measured between corresponding points on the map. Similarly, because I had measured the distance between this house and a telephone pole here, let us say D and the capital D. So capital T, D was the distance in the ground, the small d is the distance here in the map. So ideally this should be so. But obviously there might be some errors and it will not be equal. If they are not equal, then we see what is the difference. Delta D is, let us say, D by D minus SD, and then this difference in these two measurements is an indication of the error in the map. And there can be various ways by which this error can be represented. A very simple method could be to write this delta D by capital D in terms of the relative error. And you can say, well, my map has got this kind of relative error. Now, I have shown here we took two distances, number 1 and number 2, for the checking. In a large map, we take many distances, 100 distances, 30 distances in order to find the accuracy of the map. So this is very important. Whenever we make a map, whenever we do the survey, we should have a provision to find its accuracy, to check whether the map has been made as per the accuracy or not. Because you take a decision based on this relative accuracy. You take a decision whether this map is acceptable or not. Well, next we will go to another discussion which is very important and is related with the map making. And we say that because in the case of the map making, you will remember very often we had a chain line which we are writing as AB. Any object which we need to plot, for example a tree, we want to drop a perpendicular here. And the question is how to drop the perpendicular. This is important because we want to measure this perpendicular, we want to determine this. Now if you think of the ground, think of the garden in which we were working last time, or in your neighborhood, anywhere, just outside your room where you are seeing this video lecture. If you have spread the chain along about 2 points and you want to plot a third point, which may be anything, a tree, corner of a house or a pole, you want to drop the perpendicular, what will you do? There on the ground, the chain is spread here. Okay, a certain length of chain is spread here. You are standing here at this tree and you want to drop the perpendicular, you want to measure it. How will you do that? So we need to find some methods, and methods means those which we can apply in the field. The feasible methods, the practical methods. We need to locate those methods, we need to know about these methods, then only we can drop this perpendicular. So this is the problem number 1, dropping perpendiculars. Problem number 2 is setting out perpendicular. Setting out perpendicular means if you have a chain line, at this point you want to set out a perpendicular, you want to make a perpendicular at this point, at a given point. This is A and B at C. You want to set out a perpendicular. So how to do this? Now what we will do, we will try to see some instruments first which will help us in doing this. So instrument number 1 is here, and this is called cross staff. As you can see in this instrument, it is a very simple instrument. There are 2 vanes. One you can see here, I will highlight this. Okay, one goes like this and the other one is like this, and these 2 are fixed at 90-degree angles to each other. It is something like this. If I show you by hand, this is vane number 1, vane number 2 at 90 degrees to each other, and then these 2 have got some vanes here. So this is standing, and over there we have a little slit. So over here we will have a little slit. This slit is shown in the diagram here. So this is the slit and the corresponding slit here. So if you can visualize this instrument, it's a very simple instrument, you can make it. You can visualize this instrument, and I am standing at any point with this instrument, I am looking through one slit. Let us say I give the slit's name. This is slit A, slit B, C and D. I am looking through slit A. So through slit A, I am looking through the slit at B. So what my line of sight is now A, B. Now if a second person now looks through slit C and slit D, his line of sight is CD. So the line of sights CD and AB will obviously intersect at 90 degrees. This is how the instrument is made. Now how do we make use of this? If you have, so we have a line, and the line is A and B. A and B are the survey stations, and we have, let us say, a chain spread along this line. Of course this line is, let us say, 100 meter approximately. So chain will be smaller than that, 30 meters. So chain is spread in 30 meters. Now using the cross staff, the instrument, we want to set out, or first let us say we want to drop a perpendicular. Here is a tree. We want to drop a perpendicular from this tree on this line. How should we do? How should we go about? Now think of the cross staff. It's an instrument like this. We can see along 2 lines which are at 90-degree angles. Now in order to do this, we will walk along this line using the cross staff. I am showing now the cross staff as a very small instrument here in respect to this line. So here is the cross staff. I am moving along this A and B, and this A and B, they are marked by 2 ranging rods, because in the survey stations we have put 2 ranging rods. Now we are moving along this, and as well as we are seeing through this. So while we are seeing through this, we can ensure that we are moving along this somewhere here. When we are somewhere here, for example, let us say somewhere here, we can ensure that we are whether in line AB or not, because we can see through this, and it will be ensured whether the base of the cross staff is on the line AB or not. So once we have ensured it, now we can move slowly along this line, and as well as we will see through if our AB are along the slit A and slit B, if they are along line AB over here, in order to ensure the perpendicular, we need to see through C and D. So by a trial and error method, you are moving along this line AB and seeing through C and D, you ensure that this object is visible. Once this object is visible clearly through CD, then your base of the cross staff is on line AB. So this is how you can establish several points on the chain line, which are the perpendiculars from various objects. If there is a building, for example, here, in order to plot this kind of building, you need to drop perpendiculars from various corners. All these perpendiculars you need to drop on the line, you need to find their length. You will move along the line AB, keep finding these points 1, 2, 3, 4, 5. Once you have located the base of the perpendicular, the foot of the perpendicular from these points, you will measure these offsets. By measuring these offsets, this entire building can be plotted. The another job, this was dropping a perpendicular. The another job which can be done by the cross staff is erecting a perpendicular. For example, let us say there is a point here D, and you want to erect a perpendicular from D. What will you do? Again, it's the similar way. You are moving along this line AB, the base of your instrument, base of your staff, you keep at D, you keep the base at D. Once you have kept at D, then you are looking through A to B, ensuring that your cross staff is aligned in such a way that you are looking through A and B. It is aligned along line AB. Once it is so, you move across, now see through C and D. So in your cross staff, once it is aligned, now you are seeing through C and D. So again you are setting out the perpendicular. So it's a very simple instrument, nothing very special about it. You can set out the perpendicular that way at a point D. And whatever is the length of the perpendicular required, you will mark that length later on with the tape. Similarly, this was one instrument which is cross staff. You can make it as a very simple instrument. Another instrument is optical square. Now what this instrument looks like, this instrument is nothing but a cylinder kind of thing. It's a cylinder, okay, maybe made of brass, and it has couple of slits, and inside the cylinder there are two mirrors fitted at 45 degrees angle. Now if I draw the line diagram of this, so it's a cylinder and it is fitted with again maybe a little base, and we can suspend a plumb bob also from here in order to see where is the center of this optical square there on the ground, because I can hold it like this, and wherever the plumb bob is marked in the ground, that's the point where is the center of the optical square. Now what this instrument is, the schematic of this inside this instrument, as you can see here, we have two mirrors, mirror A and mirror B. Now these two mirrors are fitted in such a way that they are at 45 degrees angle. Well, again the problem is same. Here also we have a line marked by two stations A and B. The job is same. I want to drop a perpendicular from a point C on this line AB. Second time I want to erect a perpendicular at D in line AB. So it is, dropping perpendicular and erecting perpendicular. We want to do it using the optical square. Now how to do this here? Now in the case of the optical square, regarding these two mirrors, let us say the mirror at B. I am showing the mirror at B here in this diagram. This mirror at B is made in such a way, if I show you here, if this is the mirror B, half of it is polished. Polished means half of it is mirror and half of it is transparent. Just keep in mind, this is polished, this is the mirror part, and this is transparent part. Now if it is so, your eye is at E, that's your eye, you are looking through E, and if you look through E, what you will see a ranging rod which is Q. So this ranging rod will be seen in this mirror somewhat like this. So this is my ranging rod Q. Also, if there is another ranging rod at 90 degrees from this line EQ at R, what will happen? The rays from this R, they travel through this slit, pass and reflect from this mirror A. So they travel like this, they reflect, and again they reflect from the bottom part, which is the mirror, polished part. So it is reflecting from the bottom part, and then they go to my eyes again. So here in this mirror, when I am seeing through this E, what I see Q and as well as another image. So here in this mirror, in this polished part, what I am seeing the image of R. Now with this line diagram, it is very clear, if this point D is the point at the intersection of these two perpendiculars, DQ and DR, then in that case, these two Q and R should form one line. Then Q and R should be like this, they should form one line, they will become one. So the procedure of working with this is, the line diagram should be clear to you. We move with the optical square and you move till you see these two images. One is the direct image of Q, which is coming from the transparent part. The bottom image is the one which is the reflected image of R, and these two images will be slightly moving like this. Once these two images come together, so at that point this center of the optical square on the line EQ is in such a way that this DQ and DR, they form 90 degrees angle. So this principle is very clear. You don't have these optical squares or cross stuff with you. You can make them easily, of course. They are not very costly instruments, they are very cheap, but still there might be a situation when these instruments are not with you. So what will you do in that case? A simple thing. That's our chain line. A tree is here. You want to plot this tree. So you want to drop a perpendicular from this tree on my survey line, which is AB. What will you do? On this survey line, let us say my chain is spread. Okay, this is 30-meter length, chain is spread. What I do, I take my tape now. I keep one end of the tape here, stretch it and swing it. So while you are swinging the tape, it's basically you are swinging the tape like this. You look for the reading here. The reading, when the reading on the tape is minimum, obviously, that's the foot of the perpendicular. So that way, once this reading is the offset value and the corresponding reading here is the chain edge for this particular offset. So this is a very simple method, but always, not always it is possible that you can swing your tape. For example, let us say there are some trees here. Can you swing the tape? You can't, because there are some obstructions. You cannot swing the tape. If that is the case, then how to set out the, or how to drop the perpendicular? This is basically dropping the perpendicular. Okay, so another method for dropping the perpendicular could be, we have A and B, we want to drop a perpendicular from here. A method could be, you measure a distance, let us say y. You can swing your tape and you measure the same distance y here. Whatever way you want to do it, you are measuring equal distances on both the sides. Once you have located these 2 points on the tape or on the chain here, you can find the middle point. So middle point will be the foot of the perpendicular. Similarly, there could be one more method. The point which we want to plot C, A and B are the survey lines. Well, what we do, in order to drop a perpendicular from C on this line, take any distance as is convenient to you. Find the middle point. So these two are equal. Now from this middle point here, whatever is this value, let's say 5 meter, take an arc of 5 meter here also. So these two are at same distance. Well, you know this length or this line will be perpendicular. So from this point, a perpendicular has been dropped on line AB, and we can measure this offset value, whatever is the length of this, and then chain edge. So this is about dropping perpendiculars. The another thing which is important is setting out. Setting out the perpendicular. Setting out means, as we have said, only a chain line is there or survey line, and at any point we want to set out a perpendicular. Now how to do this? There could be many methods. You can start with a simple method could be, at this point C where you want to erect a perpendicular, you take equal distances on both the sides. Let us say this is also x and this is also x. Once you have done it, you take a distance of 2y on your tape. Let us say that this is the tape and I keep the tape like this. This is the distance of 2y. The ends of the tape, E end and F end. I keep the E end of the tape here and the F end of the tape here. And that's my tape here. I'm just showing it by a different color. And you know the length of the tape is now 2y. I hold the tape from its middle distance, let's say at y, and then you stretch it. Once you stretch this tape, the tape will be stretched in such a way, and we ensure that the pull or the tension in these two parts of the tape is same. Once it is so, this will be also y, this will be also y. So from this point C, that's the perpendicular. There could be another method. This method is called 3, 4, 5 method. Again your chain line AB, we have the survey stations, a point C. In the case of 3, 4, 5 method, let us say I take a distance of 4 meters or 3 meters here. Let us say it is 3 meters. It doesn't matter. I take 3 meters. Then a distance of 4 plus 5, that is 9. I take my tape, and in my tape I take a distance of 9 meters. Let us say there are two ends, again E and F. I keep the E end here and the F end of the tape here. At this point and this point, these 2 points are 3 meters apart. Then in my tape I hold it from a point which is 5 meters from F and 4 meters from E. Well, after holding it here, I pull my tape. The tape is initially kept like this, and I am holding it here, so that this distance is 5 meters and this distance is 4 meters. Once you pull it, you pull your tape it will be pulled in such a way that if this is 5, this is 4, you know by Pythagoras that this should be 90 degrees angle. So what we have done, just by using the tape, we have been able to erect a perpendicular at point C. Not only 3, 4, 5, but any set of these values, which you should be aware what kind of values, which will satisfy the Pythagoras theorem here. You can make use of those values. So this was about perpendiculars. There may be some other problems. These problems are marking parallel lines, P-A-R-A-L-L-E-L, marking the parallel lines. If there is a line AB, we want to set out a line parallel to this AB from a point C. How to do that? Well, the method could be a very simple method. You drop perpendicular number 1, measure its distance. Go to a point here, this is let us say D, you go to a point E, again erect a perpendicular on this of the same length. If this length is Y, keep it same as Y. Now joining these 2 points will ensure that this line is parallel to this line. There could be many other methods. No, your line AB, that's the point C. Take any line. If you can't drop the perpendiculars, take any other line. For example, let's say I'm showing this construction by blue lines. Any line, find its middle point. So these two are equal. Now from this middle point, join any point here, and whatever is this amount, extend this line by the same amount. So these two are equal. This part and this part are equal. If that is so, then the line joining these 2 points will be parallel to our line AB. So there could be varieties of cases like this. What I am showing you only a little glimpse. And what you can observe that we are making use of our simple geometric characteristics or principles, what we know in our high school. Just making use of those principles of simple geometry, we are able to do some of the jobs. So what we saw today, we saw how to make a map using chain and tape, and we followed all the principles, working from whole to part, check, redundancy, reconnaissance, all these things we followed when we were doing that. And in doing that, we came to know that we need to measure the offsets. We saw how to record these things in the field book, how to make a plot of those things. Then in drawing the offsets, we can draw the offsets or we can plot the offsets by various methods. This all depends upon the field condition. What is there in the field? So accordingly you have to find a solution. There might be various problems in the field, so you have to come out with a solution for that particular problem. What we saw some of the examples of some problems. Thank you.